the majority of it. The worst is over. The worst is over. It's over. The NCC is well and truly covered, especially with the thermal assessment. Unfortunately, it is no good. The problem is we've been doing a lot of the work for you all this time. And now that bit's kind of over too. And now you guys probably have to do a little bit more work. So it's good news that it's not the NCC, but it's bad news that the burden is somewhat shifting to you guys a bit more than it is sitting with us. Partly because the NCC is not a particularly accessible document. So it takes a little bit of practice. And Sandra and I are by no means experts when it comes to all this NCC stuff, but we have at least had some exposure to it over the years. So when we can hopefully help you interpret it a little bit. Whereas this part of the assessment work is a little bit more straightforward, is a bit more research-based, has a little bit more accessibility, is a little bit more familiar to you, standard construction techniques, standard building materials, that sort of stuff. It's things that we are familiar with on a fairly regular basis. So we're pushing the burden of that responsibility back to you guys a little bit. Obviously with support, lots of help, but a bit more of an opportunity to step up and take over this project and the report that you're putting together. But first what I want to do is just collectively brainstorm all the different types of materials that you can think of that might go into a building project like this. So think not specific brand names, but material types.
Are we talking about the residential?
Yep. So, but this could apply to almost any project, really. The same sorts of materials show up in every different place. Thanks. Concrete. So cement is an ingredient of concrete, but it's not the material on its own. Yep, not bad. So that's made out of concrete. Yep, so it's a product. So steel, absolutely. The big three, and there's one more to fill out the last one. Glass, there you go. They're the big ones that are really quick and easy. Whoops, too many S's. Glass, timber, steel and concrete. Nice and quick, straight off the blocks. Pardon the pun. What else can you think of? There are more. What are some of the lesser known, more unique materials that we might see in a building project? Laminate. Laminate's a process, if you like, to connect multiple pieces together. Glue, adhesive, yeah? Ceramics, yeah? I'll say adhesives, there are lots of unusual ingredients in there. Ceramic, yes? Not just for tiles. What else can you use ceramic for? Oh gosh, we're all going for it now, hold on. Aluminium. Yeah, plastics. Excellent. What else? Oh, fiberglass. That's a composite material, two materials in one. Yep. Not very common in residential, but sure. There was something else that somebody said that I missed. Block. So those kinds of blocks are made out of concrete, but can you come up with something else that's similar? Oh, goodness. So plaster, which is gypsum. And then you've got earth. Yep, earth wall construction. And what else did I hear? Clay. Clay bricks. So that was what I was thinking of, because you can get concrete blocks that are quite large, and then you can get clay bricks that are fired and they're smaller. Yep, so clay. Not quite, no. It's a special kind of earth, I suppose, clay, because you can create a foundation or a mold and put different layers of earth in and stamp it down and mix in some cement powder and make earth wall construction out of it. But clay for clay bricks is a little different, and they look a different colour depending on what kind of earth they use and things like that. So yeah, there was something else that I heard. Oh, okay. Silicons and rubbers, yes. I'll just put sealants, and that would probably do the trick. Because there's rubber in rubber seals, like on door seals. That Raven company is quite good for those. And then there's also the silicon sealants. There's glass silicon and different glues and things like that. Excellent. Ooh. So I'm just going to say metals. So you could probably divide them up. Steel is a certain kind of metal, but steel is the most common one, and then you've got ferrous and non-ferrous. So who can rattle off some other metals that aren't steel? Copper, what were you saying, Nick?
Brass.
Brass, yep. Yep. Stainless steel. Alloys, sure. Anything else? One starts with L. Gold, oof, if you're lucky.
It's in your wiring. If you're
Oh, yeah, yep. Yep. Lead? Preferably not, but still. Yep. We got the A to Z of metals. We're missing the Z. Got the aluminium, zinc. Thank you. Yep. Yep. It corrodes everything. Zinc's useful but damaging. What did I catch that again? Did you say something? Oh, yikes. Let me check my list and see if we've lost anything. Ooh. There you go. Stone. So stone as walls, stone as bench tops, different types of stone that you can think of, just, yep. Porcelainite. Yeah. So I recently went back to my old stomping ground, the Barossa Valley. They've got a special green stone they quarry there. It's called Caton Green, which is the town where I grew up, which is really nice. Really lovely stone. Very nice in as aggregate, exposed aggregate or polished concrete, just to give that really nice, yeah, really nice. So, is that a stone or is that a... It's a technique, isn't it? Yep. Marble, slate, granite, porcelainite. P-O-R-C-E-N, porcelainite, I think. Porcelainite. No, we can all leave that off, despite what Trump wants to do. And the other one you get here a lot, particularly near the city, is a coffee rock. It's kind of a red, knobbly, it's not much good for anything. Yeah, it's a coffee rock. It just is annoying when you hit it, when you're digging foundations. Not bad. That's all I've got on my list. Make sure you've got that list yourself. Good job. See, they took over the learning part just like that. Like, we're done, you're it. There you go. Beautiful. Well done. I'm going to rub that off, so make a note. I don't think it's going to be a problem, yeah. Just take my job and run with it. Love that. Have? Yeah, absolutely.
So this unit, the 401, is all about materials and basically how they go together in different construction techniques.
But they're all made of steel. And I like the rubber that you mentioned, very good, with the grommets that are underneath the cyclone washers. Remember that little flange that I mentioned? Sometimes water just needs the smallest little place to get through and it can ruin your day. So just those little things that can make a big difference. Can I rub that off now? I need the board. What was the question? Yep. They're just raw materials. Yep. Just raw materials. Yep. They get used in all sorts of different ways, which you're probably mostly familiar with already. Yep. Yep. Quite right. Now, the attributes of all those different raw materials are different to one another, obviously, for good reason. Otherwise, why would we have so many? They all do different things in different ways. There's a series of attributes that's important to know. We mentioned zinc and its corrosive attributes. So if you put zinc and other metals adjacent to one another, or have water running from somewhere in the roof that has zinc to somewhere else, it can bring that corrosive nature even to other parts of the roof. So there are attributes of different materials that you want to be aware of when you're choosing to specify them in a building project. That seems fair, doesn't it? So the idea is that we need to know what those attributes are so that we can use them wisely and not create defects down the line or even quite soon after we've used them because they don't perform the way we expect them to. What I want to try and do is brainstorm as many of the different categories, not the actual information for steel or glass, but the categories of those attributes. What are some of the things we ought to know, and I've kind of given you a big hint there already with the zinc, what are some of the attributes that we ought to know about a different material before we specify it in a project? So think bigger. The corrosiveness, yep. Compatibility. So compatibility with other materials, absolutely. I should make a note on here that I've written it down. What else? Conductibility? Yeah, I guess. May I borrow this? Do you mean if you were to manipulate it, it would maintain what you expected the size to be when you've changed it?
No, like the whole kind of solid it is and how much you can make. The load bearing.
Yeah, that's a lot of categories. I'm just drilling down. You're on the right track though, I think. So lots of materials have what we call tolerances. So you can have, it's not so much about their load bearing capacity, but just their fixability and the way that they operate, and then they've got expansion and contraction and what tolerances you will permit within that material and the adjacent material and whether it can cope. Let's think something along the lines of, I'm just thinking tolerance is probably one of the categories. You have to know what the tolerances are of that material. What is the rate of change with expansion and contraction? One sec. So I would probably say tolerance is definitely one of them. Yep, just a sec. We'll finish Birgit's point and then I'll come back to you. Don't forget that though. But there's also its consistency, I suppose, is more what you're saying is.
Yeah, I don't know the right word. If
you have it at one size and then you make it a different size, it still behaves the same way. Would that have anything to do with the way it's fixed and the framing beneath it or the substrate that it's connected to, perhaps?
Kind of like the strength.
Okay.
I don't know. Yeah.
So do you mean?
Like, let's say when you're comparing different materials.
Uh-huh.
There's copper that's quite soft, isn't it? Or
Yeah, it's very malleable. Absolutely. Yep.
I don't know. Then there's stainless that's really.
Okay, so the word you're looking for is durability. How durable is it? Yes, excellent. We did durability. So some materials don't need to be durable, or they aren't durable, so we use them in places where they don't need to be. We're not expecting something that is flexible to do any structural work, for example. So durability. But it's also about the material's longevity once you put it in place as well. So it has to keep doing its job for an extended period of time. How durable is it? So if it's very friable, like asbestos, then it's not very durable. Concrete is extremely durable, assuming it's protected because it's not completely waterproof on its own, but it is very durable. Concrete is an exothermic material. It continues to give off heat for the entire life of it. I'm sure there's a limit, but it keeps getting stronger and stronger and stronger for the life of itself. Stone may be very, very durable unless you've got water penetration. Just a constant drip can be enough to break apart a stone. So it does depend on its protection as well. So I like where you're coming from. Yes, durability is definitely one of them. What else? If you were building a house, what would be the first thing you would want to know? The first thing. How much is it going to cost? Absolutely. Cost is absolutely a factor. We can't always get exactly what we want. Sometimes we just can't afford it. We had life cycle and strength. They're not the same, but I want to come back to them both. I'll start with one. What were you saying about life cycle?
How long you want the house to last?
Okay, so that's a little bit about durability, low maintenance, but life cycle's a little different, isn't it? So if you think about the cost of, we just talked about cost, if you talk about the financial outlay per cubic metre or per square metre, that's a financial outlay, but what about an environmental outlay? So you can look up, there's a life cycle inventory database that there's some scientists here in Australia have developed, and you can determine how many cubic metres of CO2 it takes to develop a cubic metre of this material. So you can imagine concrete takes a huge amount of CO2 to develop, whereas timber is the reverse. It absorbs CO2. So as far as cost to the environment goes, creating concrete is far more expensive than using perhaps renewable, not old growth, timbers, because it takes that CO2 in and stores it for the life of its use. And as long as you don't burn it, it stays there. So energy efficiency is definitely a part of your categories that you might want to consider, particularly if the brief is about that. It's rare, but when you've got a client that is particularly invested in making sure that the environmental cost of their build is low, then this would be a consideration, wouldn't it? So completely differently phrasing energy efficiency, but the energy efficiency of the material itself. Excellent. And strength, Josh, you mentioned.
Yeah. Talking materials, but it's a relationship to what you're trying to serve, but and is related to some type of durability.
Yep. So structural with an L. Does it have any structural capability? Can it do load-bearing work? Or is it to be a non-structural element? So glass, for example, can't do any structural work. It wouldn't survive.
Does it not on concrete?
Not that I'm aware of. You can get architectural glass, but it's not load-bearing. It stays in place and it withstands wind loads and things like that, but not the dead loads of the building. Yeah, the imposed loads. Projections.
Gone into another categories, but like how the material suits in the climate.
Yeah, that'd be fair.
Like obviously, you know.
So the thermal properties, as opposed to the energy efficiency of the building, but the thermal properties of the material itself. That's fair. And we probably don't need to go into much detail about that because you've just had a whole morning there. Yeah, that's definitely true. So we basically just categorise things into high thermal mass or low thermal mass. So which example of the materials that we listed is typically high thermal mass? Think heavy. Concrete, yep. And which that we would cover more often than not with this project are we thinking is low thermal mass? Low thermal mass? Glass and the steel cladding. So high thermal mass takes a long time to heat up and takes a long time to cool down, which is why you want to shade it. Anytime you've got concrete, it's going to be a heat bank in the cool of the evening if it's had the sun on it all day. So that little handwritten note that I pumped around earlier will have a bit of information about that. Whereas low thermal mass materials like steel cladding and glass heat up very quickly and cool down very quickly. So there is a difference, and it definitely has a factor when you're designing your building, because say, for instance, if you had the opportunity to do 2 stories, you might have high thermal mass downstairs because it has the benefit of being shaded by upstairs, and you might have low thermal mass upstairs because in the evening, as soon as the sun stops, it cools down. You get the breeze through and it cools down really quickly. So that might be a good combination of mass when it comes to different materials. So you might have block work and rendered and shaded downstairs, and then high thermal mass, low thermal mass steel upstairs with good insulation to stop that hot air coming through. And then in the evening, it cools down, and it cools down really quickly. It's good theory anyway. So thermal properties definitely, as opposed to the energy efficiency of the embodied energy of the actual material that you're producing. So the manufacture of the raw products, the processing, the delivery, the installation, everything. Even the workmen that it takes to install it in the site all gets calculated. And there's more than just CO2 in this cost. It's a whole database of all sorts of different chemicals that are involved in the process. Very good. In the NCC, there were quite a few different categories that we touched on, but there's one really big one that we would want to know about our material to be compliant. Sort of the main one. What's the NCC really worried about? Fire. The fire resistance properties, absolutely. What are the fire resistance properties of the material? Is it combustible? Is it non-combustible? We talked about timber the other day, I think. We mentioned that thick timber can sometimes maintain its structural stability in a quick fire because the outside gets charred, and then that charcoal prevents the main core from being burned, if we're lucky. Not under all circumstances, but sometimes. So even though you might have some fire resistance, if you're not lucky, and then the steel does melt at high temperatures, doesn't it? All right. Now, we mentioned cost. What else would you want to know if you were building here locally straight away?
Availability.
Availability, absolutely.
Like in Alice Springs, a lot of the buildings have got the clockwork out of their quarries. You never see that colour block up here,
Yeah, right.
even though it's a nice, it's a beautiful sandstone colour. And I thought how much it would cost to chuck it all up here.
Wouldn't be worth it.
Yeah, but it's beautiful blockwork.
Yep.
Beautiful colour.
Yep. Yep.
I know when you drive through England, when you drive through England, about every 50 kilometres or so, the buildings change quite dramatically. And they change from quarry to quarry. It's all local produce, and you can really see how, you know, it's influenced the architecture. You know, a couple of hundred years ago, we didn't have the truck, so they built with what they had at hand.
So maybe we'll look back and go, oh, that was when we'll look at 2009 construction code. Yeah.
Yeah, those poor buggers. Yeah, they're just doing the best they could. Alright. And probably right up there with cost and availability is one other aspect that should be important, I suppose, to most clients. How it looks?
Oh, yeah.
Aesthetic,
Yeah?
of course.
In the end?
One of the main things your clients will be concerned with.
Yeah.
Aesthetic characteristics. Sorry, I ran out of space there. So typically you'll hear timber described as very warm, natural, that sort of thing. Concrete, not so much. Ceramic and porcelain, which is the other one that we didn't come up on the list. Porcelain, which is quite common these days, a little bit more expensive than ceramics, but porcelain is really nice, different type. Very cool, very cooling, and you want that. Aesthetic characteristics, excellent. Somebody mentioned asbestos earlier, so maybe we could think along those lines. What's one of the considerations or categories that you might want to investigate in your material? Work health and safety? Absolutely. Any work health and safety concerns. So particularly heavy materials need to be lifted, cranes, storage, oops, gave something away. So cost is, I'll put transport costs in costs, but thinking about transport and work health and safety on site, what are perhaps a consideration that you might need to consider if you're specifying a material about the way it's stored on site? So there are some materials that have to be weatherproofed while they're on site. They can't be left sitting around. Plasterboard, I think, is probably the main culprit that I'm thinking of for that. When it comes on site, you pretty much want to put it in place straight away or have it stored in a certain way so that it doesn't get deflected. You don't want to have any maintenance issues or installing issues. So on-site storage. Requirements. So transport, on-site storage, cost for transport, and work health and safety kind of all go in together a little bit, don't they? They're all related. Yeah. Doing well. There was another aspect of the NCC that we were interested in on top of fire. There was fire, and then there was another one that we were interested in as well. Anybody remember what it was?
Site-specific things like flooding and inundation.
Yeah, perhaps. I probably put that in here. That's not a bad one. I keep that in compatibility and durability. Yeah. Yep. What about acoustics? It's acoustic performance. Yeah? You can have stuff that is very adequate structurally that also performs well acoustically, but not everything is the case. So we mentioned that hollow timber frame walls with plasterboard cladding don't perform very well acoustically, and you have to supplement that with another material. So some materials are excellent acoustically. I mean, you can use plasterboard to create acoustic walls. A cinema wall, for example, is like 8 plasterboard boards thick. So you can use more of it and it'll perform really well, but you'd have to consider its performance to know how many. There's a textbook called the Red Book, CSR Red Book, which I recommend downloading and stowing away for future use. And it talks about the fire capability and the acoustic capability of all the CSR products. It's excellent. CSR Red Book. 2 words, Red Book. I think we have a copy of it on the shelf and it's mostly downloadable. Do you remember seeing it? I did get it from the rep. He did give it to me and I did say, I bet somebody, here it is, look. I said, I bet somebody will pinch it because it's really useful, but they haven't. Pass it around. What about when you've got your durable, aesthetically pleasing, tolerant, energy efficiently, sustainably designed wall built, and you want to keep water from going in? Yeah, what might you have to coat it with? So obviously you have to seal it. Sandra mentioned that the other day, sealing up blockwork. So what coatings are required? If any.
The coatings could be just sealants, they could be paints, they could be varnishes, there's lots of different.
All sorts. Might be some sort of a glue thing, who knows. Might be when you connect plasterboard together and you put where the join is, you put a bit of tape over it and put some plaster over that and then sand it back and flush it. Make it look like a whole wall instead of just multiple pieces. Then you're going to paint it. Bit more to do with the structure and building it in. What are some of the things I just mentioned just then, but what are some of the fixings required? How is the substructure going to work? What do you need underneath it to be able to use it? Some materials, like blockwork, is its own substructure, but not everything is like that. So its requirements would be categorised, wouldn't they? Substructure required and fixings. Almost there, there's not much left. You might want to identify any limitations.
So a perfect example of that would be our louver window systems in cyclonic areas. Really, our louver window systems have a limitation of being 600 millimetres wide. Now, you can have a window that's multiples of 600 millimetres wide, but they need to be in those bays, and that's for the wind pressure. Now, you can, if you've got lots and lots of money, you can pay for, toughened glass, to have a louver bay wider than that, but very rarely does anyone want to pay the premium that it requires.
Is there any conversation about how they don't perform terribly well in storm conditions due to water?
Actually, would you believe some of the newer products perform extremely well? Yep, yep. So there's been a lot of cyclones testing those kinds of louvers on the East Coast, and they've performed quite well. Certain brands, I know Breezeway was particularly proud of the performance of their products in the couple of cyclones that came through Queensland, but agreed, older louvers couldn't make that claim whatsoever. So the capillary reaction, when you have water being forced onto a window through driving rain and wind, you are going to get inundation. I can do it with the hose. I don't have to, so, yeah. Agreed, it's not great.
Actually, you're right, the Breezeway Altar is their brand name for these particular louver systems. They're excellent. They perform really well to their air sealability as well. And once you've got air sealability,
water is out as well.
you're water resistant as well.
Yeah. There was a lot of talk about garage doors after Cyclone Yasi as well, because a lot of them didn't perform as well as they ought to have. So, for example, we might have a limit of about 4.5 metres before you have to go from having just a standard roller door with a single sheet of steel coming down to having interlocked pieces of steel that perhaps could take a bit more wind load against them before they fail. So there's limits. Yep. What else? Sorry?
With our louvers, it's minimum basic 6 mil.
600 wide?
Yes.
Of the thickness? Oh, I don't know.
Yeah, and most of our single clear glass is 6 mil.
Sounds about right, yeah?
So is it
Single clear glass.
is it set as a standard?
Yeah, it's not a standard. The NCC doesn't tell you what it has to be, but that's the most common thickness of glass for single glazing is 6 mil.
So that's substructure, structure, fixing, coatings, compatibility, acoustics, aesthetics, availability, cost, defects. So typical defects. Likely defects. It's good to plan ahead and have a bit of an idea of what defects are likely to happen. Durability, energy efficiency, fire resistance, health and safety, interaction with other materials is compatibility, limitations due to the manufacturing process, limitations, maintenance. Do we have maintenance? No. So what is the ongoing maintenance requirements? So we talked a bit earlier in the piece about how if you put steel sheeting horizontal, make the pattern horizontal, it might collect dust on the ridges and then encourage moisture to collect there, and then it might corrode the actual sheet itself. You're going to get less longevity out of your material than you perhaps might like, so it needs to be cleaned occasionally. We have very dry winds for a long period of time, no rain. We've got bushfires and soot and ash and things collecting, so the build-up of dirt and muck can be quite quick in the dry season. It's worth keeping your steel cladding nice and clean so that it doesn't hold moisture.
Defect is putting air conditioners too close to ground level because the wind can't get around to clear the debris.
Sure.
A lot of people
Builds up all leaves and things.
They should actually be on 100 mil
Yeah,
minimum.
on the elbows.
Yeah, so that the breeze can actually get around
Yeah.
the unit.
Yep. It's a good idea for the unit itself as well as for leaf litter and things, you're saying, like grass clippings and
Yeah, grass clippings and all that because
spider webs.
put there and then the wind, it creates natural turbulence. Like, ideally, this height, but they
Yeah, then you've got little kids running into them and all sorts, yeah. No, that's fair. Excellent. Sorry? Yeah, only a couple of times, you're right. If they're smart, yeah. And then it doesn't matter. That's the list that I can think of. Has anybody got anything else that they'd like to add? Well done, by the way. That was excellently efficient. So, I was a bit mean and didn't tell you this, but these lists are actually on your assessment sheet. So you'll see a list of categories and you'll see a list of materials, and you're expected to choose 3 for each assessment task. So the idea is you pick a material that you can find in the project. I would recommend using timber in this current project because we have the timber framing and you won't see as much of it in the commercial project. So I definitely would cover timber. I would save concrete for AT2 because there's so much concrete in that particular project. So if you're researching concrete, it's a lot more relevant. Glass you could probably do in any of them, but we do have windows, obviously, in all three projects. So it makes no difference when you do it, AT1, 2 or 3. What else?
But I thought we were going to nominate the three.
Were we?
Yeah.
Oh, gosh, sorry. What did you want to nominate?
Oh, we said definitely timber.
Yeah, timber, definitely.
I don't know what else we just want to keep some of them, I know.
Yes, yep. We're trying to make it so that you're all doing the same thing. So either you can work together and help each other a bit, and then that marking is a bit more consistent. Definitely timber needs to be on the list. Did we write down the other two? Sorry.
I couldn't find that list, so that was the
Do you want me to bring it up?
Have a look at that list.
Sure. Just give Kizzy back his pen. Thank you, sir. Let me just bring up the assessment task sheet. It's on there, Paul.
it's in the task sheet.
Yeah. So task 1.3, it poses some questions to you. So this will be your thought process, your thinking behind research and making notes. What construction technique and materials would you recommend for the footing systems and why? So we're going to go through the footing systems that we can decide are recommended. We'll go look at the NCC and decide which ones will work. What construction technique and materials would you recommend for the flooring systems and slabs and why? What construction technique and materials would you recommend for the walling systems and why? What construction technique and materials would you recommend for the roofing system and why? It's a good way to structure your report, work from the ground up and have headings that just touch on footings, flooring, walls and roof. And then it says choose from the following materials, a minimum of 3. And there's the list there. Whoop, come back. So there is an added one there, existing and or emerging materials. Bricks, clay, composite materials, concrete, glass or glass blocks, metals, stone, timber and timber products. So as long as what you pick fits in those, you're doing quite well.
So the composite materials in plasterboard.
Now's a good time to do plasterboard, yes? Yeah. So it can be difficult to separate off sheet materials. You'll often see CFC, which is concrete fibre cement, and plasterboard grouped together. So plasterboard is an excellent generic product. It's used over and over and over and over. Really important to understand it fully. It comes in lots of different flavours. You can get them that are slightly water resistant. You can get them that are slightly fire resistant. You can get them that are slightly better performing acoustically. There's lots of different products on the market that you can get that are thicker and thinner and do lots of good work. They're extremely versatile. You can use them in curved spaces. You can have them moulded. It's a terrifically inert, fire resistant, low spreader frame index material. Very versatile. So I would definitely recommend, what have we got? Timber, glass and plasterboard, which would be a composite material. So they would be my recommendations for this particular project because they don't show up in AT2 or 3 as well, as much. And these are the different categories of research you do each time for those 3 different projects, 3 different materials.
So in your report, you just pick the material, you write these headings that you've just brainstormed there now, and you make a comment on that material under each of those headings. That is your report.
It's a big section of the report. Well, plasterboard is a composite material because it's gypsum, plaster and paper.
Slash plasterboard.
Yeah.
Plasterboard product. So for AT1, you will be doing timber and timber products. We'll be basically talking about structural timber. And then the next one will be composite materials, plasterboard, and the next one will be glass. And you can certainly look at louver windows for this one, under glass. But it's not about the window or the type of window, it's about the product, about the glass or the material. What are the properties of glass? There's lots of research that we can do on it.
I'll just send around a little example of some research that somebody's done in the past, so you can have a bit of a look. Lots of images. You can often say quite a lot with an image that you can't necessarily write out easily, so I definitely recommend using images. I don't want to see any cut and paste from the internet. Summarise in your own words, keep it concise. If there's any cut and paste, it'll automatically be a resubmit, so that's a big no-no. But in your own words, and we've got stacks of information for you, and obviously your textbook is a good source of information as well.
So we can cut and paste it, we can cut and paste it.
Yeah, we just,
back into the internet.
that's right, reverse engineer it. I'm very good at it actually. Yeah. So there's a couple of examples floating around here. There's one. Whoops. Feel free to have a bit of a look. So for each of your chosen materials, research their application in the building project, the coatings required, the compatibility with other elements, the fixings required, the structural application, the substructural application, and its use in specific construction methods or systems.
And do we want to talk about that now?
No. And then also their acoustic properties, their aesthetic properties, availability, costs, likely defects, durability, energy efficiency and fire resistant properties, health and safety issues, interaction with other materials, limitations due to the manufacturing process, maintenance requirements, structural safety, sustainability features, thermal properties and any tolerances. Now for some materials you really can't comment. You might say this material has no structural capability, and that's the end of the conversation about that. Glass has no structural capability per se, certainly not in comparison to steel or timber or concrete. So you would say perhaps limited structural capability. It has the ability to hold its own weight, but that's about it. So in some instances, the way you address a topic is by saying that it doesn't achieve anything under those categories.
And just remember too that you know, we really, you're at the beginning of this 1-year course, you know. Let's stick to the materials that are commonly used in Darwin, that you will want to know about in your career. Yes, you can go off and do research on, you know, how to make, you know, I don't know, clay bricks or something like that.
Oh, that bioconcrete, yeah, it just grows itself and all that sort of stuff, yeah. It's not available.
But the reality is it's not going to be much use to you in your working life. And, you know, it's going to be a lot easier to find the research material that you want to find for the more commonly used products. So don't make it hard for yourself.
Remember that folder with all the materials notes in it?
Yes, but I haven't seen it for a long time.
Okay. All right. Well,
We'll have to have a look.
yeah, I probably shared it with you, but it may not have gone any further. Like, so we can make another folder with it and just bring all the same notes across from V Drive. So what Sandra's going to do is make a folder available to you. Oh, there it is, materials. Never mind. Never mind. Stop looking. Here's one I prepared earlier. So under CPP BDN 4001, which is predominantly the unit that this is involved in, there's a folder called Materials, and there is a whole bunch of research in there. I do advise staying away from the internet. Don't Google. It's too much. We only are really looking for a paragraph. You can see in the examples coming around, we're only looking for a few lines on each and then an image if that's an appropriate part of it. We're only looking for a few lines of the most key information. Don't feel like you need to give us, you know, the entire encyclopedia on the history of stone. It's not necessary. Think about the application of it in this project more than anything. So tailor your information to suit the project. Don't feel like you have to give us all the history of, you know, sand that makes up glass, things like that. But I do want to know what the ingredients of glass is. There's only 3, so it's reasonably easy just to say the 3 things. There's more than 3, but you can leave the others off. They're so minuscule. You get the idea?
The core ingredients.
Yes, the core ingredients. So what I want you to consider is using these resources rather than the internet, because they are quite concise, and even these are greater than I would need in return. the other place that you might like to go, which is okay on the internet, is the formal association for this product, for example. So there's timber.com.au is a website that is an association that advertises a good idea to use timber. They're not too bad as far as reference materials go, but again, beware because it can go on a bit. So just keep it nice and simple. Don't feel like you have to go too overboard. The other place, obviously, you can go is your textbook as well. And that would be more than enough for us. Does anybody have any questions about that? Does everybody have that folder, materials, in the 4001 cloud? Should be there for you. Now, buyer beware when it comes to a few different things. So we talked about concrete. So watch out when you see bricks. Bricks are definitely not concrete, that's blocks. So you'll normally see blocks for concrete and bricks for clay. So just be aware of that. Then there's masonry, which can be concrete or stone or clay or earth wall. So you have to be a bit careful because masonry can be all sorts of different things. So as you're researching, make sure you sort of tease out which actual material they're talking about. Then when you see blocks, you might also see a product called autoclaved aerated cement, AAC, which is similar in shape but much lighter and has a lot more air in it than traditional concrete. So just be careful about what you're reading. There is a bit of information in the materials about those as well. And then, of course, all the different metals. So we talked about ferrous and non-ferrous metals. That's with iron or without iron. And then there's a whole list of different metals that you can research. But the likelihood that you're going to see copper or gold or titanium or anything, aluminium we see a lot of, steel we see a lot of, but the rest not so much. Yeah. We don't smelt iron here. No. That's an East Coast thing and perhaps a West Coast thing as well. Mostly Newcastle, I suppose, comes to mind when it's taking the raw iron ore and turning it into. We do cold rolled, but not hot. So we buy everything in and we can shape stuff that can be manipulated cold, but not the hot rolled. That's not something we can deal with here. So you can get a big piece of flat, thin sheet and shape it. That's okay, that we can do. Yeah. Good question.
There's not a whole lot of materials locally produced in Darwin.
No.
Unfortunately, we don't really have a long history of buildings in Darwin. By the time Darwin was being founded, buildings were being, we already had transport systems. We do have some quarrying. Did you guys blocks here?
Yep, lots of concrete, fixing, batching.
Yeah.
All right, so a little bit more brainstorming, and this will be nice and easy. I want to brainstorm the structural parts of buildings and some construction systems. So I've kind of given the answer away a little bit with the assessment task sheet. Think from the ground up. What are the names of the structural systems that you want to be relating those materials to in your construction project? Foundations is the dirt. So I'm thinking out of the ground. Slabs, footings. Yep. So footings is probably what you start with. And then what? What goes on top of the footings? So the slab, yep, which is the floors. It's not always a slab, the floor, but the next level up is flooring, isn't it? Yep, the floor, excellent. Then what? Thinking about this particular project, what might be a layer in there between floors and walls? Yeah, go on. Columns and stumps, yep. So these are a bit interchangeable, aren't they, depending on which one comes first and how many stories you've got. Columns and stumps. So they're pretty much the same thing, except columns tend to be taller and more slender, and stumps tend to be shorter and wider. So you might have a steel column and a brick stump, or a block stump. So I'm thinking about timber-framed homes in, you know, the northern tablelands of New South Wales, and they've just got little brick stumps everywhere underneath, and then they start the floor above that to get it up off the ground a little bit, but it's clad down across the front and you can't even see them. You ever hear people say, oh, I have to get my house re-stumped? Hear that? You ever heard that? Well, over the years they deteriorate. We're talking 100 years. They do deteriorate, those stumps. You have to get the house picked up a little bit, fix them all up, and then you can put it back down again. Yeah, re-stumping a house. Cool, so we've got footings and columns and floor, or floor and then columns. So in our instance, we've got footings, floor, some walls and some columns, and then another floor, haven't we? If I was to build it up, we've got a section down here which will be the footings for our columns, which we'll have rising up, but we also have our laundry walls in there, don't we? And then we've got more flooring, and then we've got walls. Would that be fair? So you can have a couple of these to start with, couldn't you? Different combinations. Wow, walls. And then, put the hat on, the roof system, yeah. Cool. That doesn't look right at all. Dear God. When I was little, I used to draw chimneys like this. They were always perpendicular to the house. Yeah, what's wrong with that? Reasonably straightforward. Yeah? So just keep that in your mind all the time. I'll put foundations up here as well. Bless you. So the foundations are important. Typically, you'll have earth that is compacted enough and stable enough to be able to dig trenches in it and build the footings in there. If that's not the case, you might have to bring earth in and compact it down yourself. Either way, you need a good solid foundation before you dig down. And for this instance, where we're going to dig down, we want to dig down firm enough, down far enough to get into firm natural ground, particularly because of the flood risk of our site. So we might have to go a fair way down. We don't really know until we start digging. Excellent. So make a note of the list. I would perhaps put floors after columns and stumps formally, even though you've got a few combinations of back and forth, back and forth. I'm going to rub this house out before I have to look at it any longer. That's just terrible. Room made of pizza. Anything I missed? Any questions? No, foundations is the dirt, footings is the concrete that goes in them. Now we've already got a pretty good head start of what our construction system is most likely to already look like. We're already miles ahead of what we would recommend. We're not going against the norm, we're not going against the traditional, we're sticking with what the client wants is traditional. We've got to bring it up to code, but we've already got a pretty good idea of what we're going to be building with. Can we name it? Can we label what the type of construction is? That's the design layout, but the type of construction? It's not steel, no. You're halfway right. What are we buying? What are we getting? Well, it's funny because you're probably right, it is technically now prefabricated, but it wasn't originally, so we wouldn't probably give it that classification. Prefabricated, does anybody not know what prefabricated means? No? All good? Yeah, I'm going to put that because that's a construction technique. It's its own thing. Oops. Cool. But prefabricated can be made of lots of different things. What's this one made of? Yep, timber framing. Timber frame construction. Excellent. What else are we getting? Or building, proposing. I shouldn't say getting. Yeah, some blockwork as well. Blockwork walling. So technically that's masonry, but we use a specific description for that. We say blockwork because, like I said, masonry can be all sorts of different things and we don't want to get misunderstood. So we just say blockwork, and that's those concrete blocks over there.
I said there was because on the blockwork.
Yeah.
I objected to blockwork really.
You don't like blockwork?
Not structural. Not in this building.
In this instance, it's not structural. No, it's not. But it is a structural system. Yeah.
Other things provide structure.
Well, yes, the timber frame providing structure, supporting the column going up, and supporting the timber frame first floor that the whole house is constructed on. We're just going to build in a laundry underneath that with blockwork. So really the blockwork is just providing walls. It's not providing support to any of the buildings. So
Just call it infill. Yeah.
That's quite rare. In most scenarios when we use blockwork, it is structural.
Yeah.
It will bear the weight of an upper floor or the roof onto it.
What other structural systems can we specify if we were to be so inclined? So you mentioned steel? What kind of steel? Okay, so structural steel, like a commercial structural steel? Okay. Sure. All right. I'll just put steel. Yeah, that was where I was heading, but that's different than what Paul was suggesting, isn't it? You weren't talking about steel framing. No. Yeah. You mean? Yeah. We'll just say steel structure. It's typically overkill for residential construction because the loads aren't that great, and it would be an expense that perhaps wouldn't be needed. I have seen plenty of structural steel detailing in residential where the spans are significant. Big wide open verandas and things, you might have a PFC bearer, a beam that then they leave exposed and you can see it. So it does happen. Yep. Yeah.
See what everyone has is the steel between the ground and the first floor. So you have the post steel, you'll have some steel beams, and then they'll have a timber structure, the timber floor joists will sit on that, and the upper floor will be timber framed. We do that in Darwin a lot because of termites. We try and keep the timber up off the ground level.
Yeah. So Despina mentioned steel framing, so that's another construction system type that you can use in these areas. And this steel structure would work for the columns as well, so we could count that in there. What other structural systems can you think of? Not necessarily for this.
Log cabin.
Log cabin. Oh my God, sure. Log cabin. Oh, that's cute. And what are the logs normally made out of? Like the green stuff. Copper log, yeah, it's treated. And you can't burn it, otherwise it's like cyanide or something. That was not. What is it? Arsenic, that's it. Yeah. Just don't lick it. Rammed earth, thank you, yes. I was hoping you'd bring that one back up again. Yeah. There's a nice example of it on, what's the road that leads to the hospital? Is it Trowell Road? Comes all the way around? Yeah, it's Trowell Road. It's got a big veranda coming down quite low, so it's hard to pick, but it's a lovely example. And I did see one being built in, I want to say Parap. I'll have to check that. Yep. No, there's a few up here. Yep. It's not too bad. Just got to do it in layers. There's a couple of architects. Stephen Scully, I think, his place is rammed earth out at the Howard Springs Community Village, Solar Village. His place is out there. So yes, you're right, Stephen Ehrlich. So there are a few around. You've got to put a bit of cement dust in the mix here, and you've got to have reinforcing in it so that it can do the chain of strength, but it's doable. Yeah. So you create a shape, a form, and then you fill it in layers and stamp it down, and then you take the form away, and it stays put. absolutely. You can get layers like sand in a jar. Yeah, it's kind of cool. Performs really well. It's usually quite wide, usually the 200 thick, same as blockwork. High thermal mass. Rammed earth, or adobe, is the other word for that. Adobe. Precast? Is that what you're saying?
Yeah, like
Precast panel? Yep, like tilt up. So you bring it in on a truck and then put it in place. Yeah. Again, not typically for residential, but it is a system. Yep, absolutely. It's not structural either. So normally there'd be a steel frame and you would connect it to that. Yeah.
You have a post and beam construction, so you have a frame, which is structure, and then that would fit in infill.
Yeah, there are some houses which are like kitmans, yeah, like exactly what you're saying.
Thanks.
And there's one at the corner of Leacoin Road and Vanilla Drive, I think. That one there is covered in shrubbery, it's ground level, right beside his high house. That one there is panels. And I think it was very similar to a couple of others. And you can just see a joining strip. They're a complete panel with a window and everything.
Yeah, you can have, they stand together and they've got openings and they've got services through and everything, but they're just holding themselves up. They're not structural because they're just connected together. Yeah, like Lego.
It needs to be connected to something else. You can't say it's done there on their own.
No. Yeah, that's okay. So post and beam and precast walls. Yeah. So very much a commercial technique because of the speed on site. The idea is that so much else can be happening and then the walls go in very quickly, and curtain walls if they come along as well.
And it only really becomes cost effective if you're repeating the same panel a long time.
Yeah.
Because obviously they got to make a mould to make that panel originally. And so if you've got like all different panels with all different window cutouts, it's not cost effective for domestic construction.
No. It's good for commercial because concrete has to set for a significant amount of time before you can use it or continue building or, have it do any performance or anything like that. So that can happen off-site where all the other earthworks, commercial sites normally have to be quite significant site works, dewatering, getting all the water out of the site and things like that, especially if you're digging down in basements and what have you up here. So while that's all happening, the concrete can be poured and cure and then gain enough strength to be able to be shipped in and stood up and performed straight away. So it's really cost effective. What else have we got? So I put adobe and rammed earth together. There's a lot of similarities, but adobe doesn't necessarily have to be rammed. It can just be built like mud. You can make bricks out of mud and build them up and things like that. So either or on that one, and you can render it. Or there's another one that's a little less mainstream, but in that same sort of field. Does anybody know? Want to have a guess? There's another one. Straw bale, yeah. Yes. Well, plastic containers and car tyres are a little, that's well outside the NCC. Yeah. I'm a huge fan of Mike Reynolds. Huge fan. I would love to go on his Earthship Bioarchitecture Academy course and build a house out in the middle of nowhere. I think it would be terrific. So if you can't get your hold of me one day, that's where I'll be. Yes, that's true, sure. There's some fantastic framing you can see overseas, Bali and different places. They've got amazing frame roofs and then the palm fronds on the top.
Can I talk a little bit about masonry veneer?
That was my last. I've got like 2 bits, that's okay. So, no, it's all good. So masonry veneer. Away you go. Grab a microphone. Did everybody catch that? Masonry veneer. Oh, good. Sea containers. Prefabricated?
Yeah, shipping containers. They're prefab. Masonry veneer. I think this is one that lots of people get confused at how the structure is working with masonry veneer. So, you just draw a little bit here. And you just give me a little corner. That's fine.
Still good. Oh, lucky. Oh, too far.
So, we build houses in Darwin with single skin, my lines are not straight, single skin blockwork, okay? And that is structural, and it's also the veneer. It's what we're looking at on the outside. It's also what we're looking at on the inside quite regularly. Quite commonly down south, they will build a house with a brick veneer. So they still have the concrete block, which is still the structural component, but they will build a cavity. Oh, sorry, my lines are just so not straight. I have to remove. So this is their block work. Or sorry, this is their brickwork veneer. So this is external, internal. The internal leaf in cavity construction is always the structural leaf. So even though both of these are masonry, this is block work, and this is brick, this isn't doing anything structural. This one is, and they will bear the roof onto the internal cavity. What you may see in other forms of construction is brickwork, veneer, it can be blockwork veneer, whatever masonry veneer you want, and then you may just have your internal cavity maybe just be timber, maybe like a timber frame or a steel frame in here. So when you look at that building, you look at it and it looks like a masonry building for all intents and purposes. From the external side, it looks like it's masonry construction, and you may very quickly assume that it's load-bearing masonry, but it's not. It's the frame of the internal cavity that you need to identify what the structure is. So this could be the timber.
So that's why it's classed as a veneer.
That's why it's called veneer. Okay, so this is blockwork structure, this is a timber structure, or steel, that could be steel either. It's veneer means it's skin. Double brick house, yes? Yeah. Yeah, always the inside wall is structure. So this could be blockwork, or it could be brick structural. To be honest, I haven't worked down south a lot in Australia, and I've never worked with a brick internal structural wall. And I know overseas I've worked with lots of cavity construction, and I've never seen brick used as the structure of the building. It's always been brick on the outside as the veneer, and then another form of structure on the inside cavity wall.
Where is the choice coming from?
Sorry?
You know, going back to our categories,
Yeah.
is it coming from an aesthetic choice?
It does good thermal work. It does good
Yeah.
acoustic work. It's available. So when you think about Australia in the 50s and 60s, bricks weren't readily available. They were scarce until manufacturing really got going after the war. But initially, framing was more readily available, and it was asbestos cladding. But in the austerity out of World War II, bricks weren't available for a long time. So sometimes it was about availability. Sometimes it was trying to give the appearance of more sturdy, rock solid, brick veneer, brick and tile. That was the taste. It's
probably coming from Europe. It's huge for Europe.
Yeah.
It's
an English
with
thing we brought over.
Yeah, it's definitely English and Irish thing.
A lot of stone was
these
used.
2 layers because over there it's very damp, a very damp climate, and so to prevent water tracking through, so they found, and there's lots of older houses in Ireland built with just single blockwork, and they'll find that the water will travel through the masonry joints eventually in a single leaf. So what they do is they allow that to happen on the veneer, on the external one. They allow the water to come in here and run down the inside wall of the cavity, and there's a tray in here which you'll have like that does something like that, and it'll catch the water and bring it back to the outside, and then you know that your inner leaf is always going to stay dry. It's always going to be the dry inner leaf.
And the nifty part, because you have to connect these two together, otherwise the front one will just fall forward. And you use little brick ties that will connect here and come across and go through in the mortar. And they have a little divot just here, and it's like an encouragement of the water to drip down onto that tray. It's really nifty. And then you'll often see bricks that have holes in them for ventilation. You don't see them as much these days. Everybody wants to seal up their buildings completely, so condensation is a much bigger problem these days than it ever used to be. But you used to get aerator bricks in, either up high or down below or both, and that would let the moisture circulate and dry out.
Yeah, dry out the cavity. Yeah. So when we talk about veneer, it's never the structure. And also the veneer is as it says, it's just a veneer. It's just a base that you've put on it. But something behind that is doing the structural work. And when you're looking at a set of plans, you need to identify the structure. Yeah.
I think we did have a manufacturing plant for bricks here for a while, and before it shut down there were quite a few bricks manufactured, and they were probably concrete, or they were just brick shape, or there was some bricks available. And you can sometimes see a double skin in a lot of housing commission homes, and they're just 140 long, and they're sort of brick shaped. They're a bit unusual. They're not the standard clay brick shape that you might expect, but you do see there are a few double walls around still like that. If you're doing extensions and renovations to something that's a little older, you might come across the manufacturing plant. Yeah, right. Somebody very original, Darwin. Yeah. Yeah, right. Does anybody have any questions about masonry veneer? You can get reverse as well, where the masonry might be on the inside and timber framing on the outside. You have the weatherboard facade on the outside and the exposed brick on the inside because they particularly like it. It's not my personal taste, but I know plenty of people who like it.
Yeah. And just the important part to remember is one of those leaves is the structural one, and it's generally the internal one. You don't usually see it as the external one.
Like the Queenslander style, you'll see you'll have just a tongue and groove wall at the interior, and then you'll see the structural performance on the outside.
Yeah, right.
Yeah, that's kind of typical North Queensland thing, which is as an efficiency. It's kind of the envelope isn't trying to do anything thermally. Your thermal comes purely from your veranda, and then height.
Yeah, right.
Quite typical.
Yeah, convection current. Excellent. So there's just one, perhaps, aspect left that I won't make you try and guess, but it's with regards to the roof. So there are a couple of different ways the roof can be manufactured, and up here the most common one is with prefabricated trusses. So I call it a truss roof system. It's where there's a series of trusses designed and built together. They look a little bit like that. So they're quite tall, narrow triangles. The triangle's very strong, and then it's made up with a series of triangles inside the triangle to do the structural work, and we just line them all up and then put battens over the top. And I'll go into a bit more detail about that another day. But the alternative is a traditional roof framing where you build the roof. This one is brought in on trucks and all lined up and connected together. So these are manufactured off-site and certified by the framer themselves. Traditional roof framing is done in situ, on-site. So you build the roof on the house, piece by piece. It ends up being roughly the same triangulation because in the end that's quite strong as well. So the traditional roof framing is made of individual pieces. And we'll look in the NCC at all of that and all the different names that you'll have fun remembering. So traditional roof framing and truss roof systems are the other two that I wanted to add to that list. Just about.
What, the truss roof? There's limitations to the truss roof. The truss roofs are very well engineered, so they basically, because they make them off-site and they make them in a factory setting, they get the member sizes for all those different pieces of timber that make it up to the minimum they can be. So it's lightweight, it's lighter to transport to site, whether it be timber or steel. Yeah, it's very much a factory, very engineered, calculated way of making your roof. The more traditional way was just to cut timbers on site and build up your roof, and that was more of a rafter system. If you're ever working in an area where you might use the attic space, a traditional cut roof is a much better option because with a truss roof you can't get rid of the W. And if you ever want to use that attic space, you've got the members are all there, the web members, the W members are all there, and you can't cut them out. They're a vital component of the structure of the way that the loads are being transferred within the truss roof system. All of these members of it, you can't cut them out. If you wanted to build a room up there, you probably want to look more at a rafter system that has cut out that square box to give you an actual room in the attic. Not an issue here in Darwin. Our pitches are too low, and as we've looked at, nobody wants to live in the attic here anyway. It's way too hot up there.
Or it might fly away in a cyclone and goodbye attic.
Yeah.
Yeah, that would be bad. Like Dorothy.
Like a plywood.
It doesn't. A rafter system can be in the same shape as a truss as well. Yeah.
Single pitch.
A monopitch roof.
Yeah.
You have that's a rafter roof.
Yeah, that's not a truss system.
That's a
Yeah.
roof. It's not truss. Truss will always be reasonably even. You can get one side to come down more than the other, but they'll be reasonably even.
So a handy resource, I've already mentioned the CSR Red Book. If you haven't already found that, jump on the internet and find CSR Red Book. The other reference I want you to have regularly is the Lysart Referee. So I've already mentioned that we smelt and manufacture steel here in Australia. BlueScope is, so I think that used to be, what did they used to be called before they were BlueScope? They used to be something else, didn't they? BHP, yeah. Didn't they used to be BHP? Way back in the day? Anyway, so the Lysart Referee is a Ready Reckoner, there Sandra has it, online resource or a physical copy that you can pick up from their office. It's a really good Ready Reckoner for steel sizes and lengths. If you have a choice to design a certain length product, you could pick something that comes standard from Lysart so that there's no waste. Or you might consider if everything's in multiples of 8, then you're going to buy your steel in lengths of 8. If it's in multiples of 10, you're going to have 2 meters left over every time, or, you know, so it's handy to know sometimes what lengths your materials are coming in. There's also some set out manufacturing systems for some of their lightweight products, which you can have a bit of a look through there. We don't typically use those here because they're not cyclonic. These are national, and so everything's non-cyclonic. So we tend to go a little bit over and above what they ask for with that. But please look up Lysart Referee, and you can click here, see the link, Lysart Referee. If you want the address, grab it off the top of the screen there.
And Lisa mentioned something there, and I think it's really important to think about this too when you're getting familiar with your materials. They all do come in standard sizes, and it's really important for you guys to get familiar with like the size of a plasterboard sheet or the standard sizes that the steel is cut to. If you are designing and you don't realize what the standard sizes of things are, you're going to have a lot of waste material from your construction, or your client is going to have to pay for a lot of custom made pieces of steel or perhaps timber for a cut roof or all of those things. So to keep costs down in construction, the designer needs to be familiar with the standard sizes of the material. What kind of dimensions do they come in as standard?
Which edition is floating around, that Lysart? What edition is that, Josh? 33? Yeah. So look up the 33rd edition, and you should be able to download it as a PDF and pop it in your cloud. And the same as the CSR. No. You don't want that one. It's weird that the link isn't on the site. We have this issue every year. I do apologise. So I just Googled Lysart Referee 33rd edition, and you can see the PDF is the second entry on Google. So. Is that not the nice? Oh, that's the heritage one. That's cute.
The 33rd one is
32nd.
33rd commemorative edition. Good.
Which one? Did I miss the wrong thing? Oh, this one here, commemorative. Is that our nice one? No. That's the fancy. No, see, it shouldn't be this hard.
So it is a commemorative edition, so it might look very old.
Yeah.
Flag.
We might have to ring our local rep and just say,
Can we bring in some?
explain yourselves. No, it shouldn't look old because the one that I've got doesn't look old. I think it's got a brown picture on it, but the actual... And every year, somebody volunteers to go out to the office and pick up a bunch. They only print a few, so they always make me feel bad for coming and collecting so many. They will send them to you. If you ring in the BlueScope office, they will send them to you for free. Now, I won't jump into soil classification now. What I might do is just make a note on the board of the chapters in your textbook that are relevant to everything we'll be covering for the next few days. So what we're going to do is learn as much as we can about construction systems through the context of the project. But we want you to also get as much of an overview of all the other types of construction as you can. It will come up again in AT2 and AT3. So AT2 we cover blockwork and poured concrete in fairly decent detail. And in AT3 we cover a bit like what Paul was talking about with structural steel and then just a skin applied, but also structural blockwork and precast concrete there as well. In your Wilkie textbook, either from the library or the one you've purchased, there's chapter 23, which is about sites.
From the library.
Yeah, there's lots of copies in the library. The base is chapter 24, and site preparation is chapter 25. So the focus of this textbook is predominantly residential, so you won't get too carried away in this book with commercial information. Footings is chapter 26. Drainage is chapter 27. And retaining walls is chapter 28 if you're interested. So that's very much about the site itself, getting out of the ground, if you like, which seems like a lot, but it's really important. I mentioned my poor neighbour that did a huge excavation and then built according to the soil they took away, and they've had nothing but trouble ever since. Can't sell their property, they've had insurance claims, court cases, headaches, stress, years, and they're trapped there. Their family got bigger and they couldn't sell it. They excavated 5 metres and then built according to the soil class that was originally determined, not after they'd done the big cut. So they dug down significantly, went to unstable soil in comparison to what was originally tested, and then still built the same way. Not them personally, they weren't owned a builder. The builder did it, but they've had uneven movement for the whole time they've lived there. And they've had tiles pop all the time. Once a year they have to retile, like redo the glue and grout and things. They have walls that crack and they separate, the doors won't open and close properly, the windows don't open and close properly. It's a nightmare. Yeah. It's getting to the point where they're prepared to give what looks like a very shonky idea a go, which is where they squirt, it's like a compound underneath to try and raise it up and balance it out. But you can't stabilise the earth. It's just about impossible. Yeah. So I can't emphasise how important making sure that you have good foundations, or if you had bad foundations, know what you're dealing with and build accordingly. There's nothing wrong with having bad foundations. If they had built lightweight construction or using a raft slab that was able to accommodate that movement, they would never have had a problem. They just simply built for the wrong soil class. Yeah. Yeah, that was fixing pop tiles indeed. I had a colleague ask me what could create pop tiles, and that was the first thing that I thought of, was the inundation of a wet season and movement. And then going on to the structural systems, so stumps and columns are chapter 29. 28 was retaining walls. So we cover them in a little bit of detail in surveying. Stumps and columns is 29. Floor systems. So we've got timber, which is chapter 30. Steel, so pay particular attention to that one. Steel is chapter 31, and concrete is chapter 32. So we want to have a little bit of a look at the concrete one because our main floor on the ground is going to be concrete underneath the laundry. So a little bit of reading on timber and concrete to begin with. Now for wall systems, there's quite a bit. And this is over the next 3 weeks, so don't feel like you have to do all this tonight or anything. But wall systems is quite significant. There's an introduction, chapter 33, and then they cover timber, steel, brick veneer, AAC, which is that autoclaved aerated concrete that I mentioned. They talk about cladding, masonry, and linings. So from chapter 33 to chapter 42 is all walls. Obviously, chapter 34, timber, is your main emphasis. Chapter 34. And when I say a chapter, it's like a page and a half, maybe 2 at most. We're just looking at the facing page and the page behind. And it's very readable. I don't think you'll have any problems getting ahead if you wanted to read up in the evenings.
What chapters?
30, 31 and 32.
Oh,
Yeah. So I'm just giving you a big sweeping overview. Don't feel like this is between now and tomorrow or anything like that. Just big introduction to construction and materials. Windows is chapter 43. Doors is chapter 44. Where would we be without windows and doors? And then roof systems, similarly to floors and walls, have quite a few different systems, so we've touched on these already. There's the different types. They talk about conventional framing, trusses, so chapter 47 for trusses. So from chapter 45 to chapter 52, but trusses is chapter 47. And what else have they got? Flat roofs, which was what David was asking about. Tile roofs, sheet roof, chapter 50. So trusses and sheets. Ceilings, chapter 51, and details, chapter 52. So ceilings is probably a good idea. So we'll look at some of those in more detail tomorrow. What we'll be doing is looking at it in the context of the NCC and the project, and this information will serve as excellent background. I'll leave that up so that you don't have to worry. So anybody have any questions? Well done.